The Fourier series is a mathematical tool used to represent periodic functions as a sum of sine and cosine functions. It was developed by the French mathematician Jean-Baptiste Joseph Fourier in the early 19th century. The series is named after him in recognition of his work in the field of heat conduction. The Fourier series is based on the idea that any periodic function with a well-defined period can be expressed as a sum of sinusoidal functions. This allows us to analyze and manipulate periodic signals in terms of their frequency components. Let's consider a periodic function f, x, with period t, defined on an interval, a plus t. The Fourier series representation of f, x, is given by f, x, equals a, 2 plus sigma, a cos, n omega x, plus b sin, n omega x, where a, 2 is the average value of f, x, over one period t. A and b are coefficients that determine the amplitude of the cosine and sine terms, respectively. N is an integer representing the frequency component. Omega equals 2 pi, t is the fundamental angular frequency. To calculate the coefficients a and b, we need to compute the following integrals over one period t. A equals 2, t, integral a plus t, f, x, cos, n omega x, dx. B equals 2, t, integral a plus t, f, x, sin, n omega x, dx. The integral is evaluated over one period of the function, and the division by t is necessary to normalize the coefficients properly. The coefficients a and b represent the amplitude of the cosine and sine terms at different frequencies. The larger the coefficient, the more important that frequency component is in the Fourier series representation of the function. The sum in the Fourier series includes all integer values of n. However, in practice, we often consider a finite number of terms to approximate a function. The number of terms determines the accuracy of the approximation. As more terms are included, the Fourier series representation gets closer to the original function. The Fourier series has numerous applications in various fields, including mathematics, physics, engineering, signal processing, and image compression. It allows us to analyze and manipulate periodic functions and study their frequency content. By decomposing a complex signal into its constituent frequency components, we can extract information about the signal's behavior and perform operations such as filtering, modulation, and demodulation. It's worth noting that Fourier series are generally applicable to periodic functions. For non-periodic functions or functions defined over finite intervals, the Fourier transform is used instead, which extends the concept of Fourier series to continuous and non-periodic signals. Regenerate response. Free research preview. ChatGPT may produce inaccurate inform.